This problem right here is exactly the same as the one we just did. Notice if I'm going to loop-de-loo, because that's a logarithm, if I'm going to loop-de-loo, I need a number here. Well, what is the base in an ln problem?
10.
No, 10 is the base in a log problem.
Isn't it E?
It's E, yes. So if you don't have this already written down, make a little note of it. ln is log base E. log is log base 10. So neither one of these two notations are going to have a base shown. You're not going to see a base in either one of those. You need to know that if it's log, the base is 10, and if it's ln, the base is E. So I'm just going to sneak a little E in here, and now I'm going to loop-de-loo. So E to the third equals X. Done. That's your answer. Now in a few days, hopefully soon, we're going to be doing some word problems. And in our word problems, if we're going to try to figure out, how much money will be in our bank account in 10 years, we don't want to leave an E in that answer. We're going to want to have an actual number. So at that point, we'll type that in on our calculator. But right now, that's good enough. E to a power is fine. Okay? Now, this guy, what are we going to do with him? Well, you have two options. If you're using your notes, and we've got several examples in our notes, you know the little formula, and it's not even really a formula, it's just the way we do it. The technique for this kind of problem is the log of 15 divided by the log of 6. It's the log of this number over the log of this number. And we'll just type it in on our calculator, making sure we close the parentheses. And the answer is 1.5114. Now, if you forget that, or you're just trying to be consistent in the way you approach all the problems, you can actually do this problem the way we did the two I just erased. Here's what I mean. Let's set it equal to X. I mean, after all, you're trying to figure out what this equals. So we'll just say, okay, what does it equal? It equals X. If I loop-de-loo that, if I do a loop-de-loo on that, I'll get 6 to the X equals 15. Would you agree with that? 6 to the X equals 15? Now, I want you to think about the problems we did yesterday. You can't raise 6 to a power and get 15. 6 to the second is 36. 6 to the first is 6. You can't get 15. So we need to get that exponent off of there, just like we did yesterday. Who remembers what we did to get that exponent down? How did we do that? Oh my goodness, we just did it yesterday. Who remembers? Oh my goodness, we take the logarithm of both sides. Because that super special property of logarithms says that you can pull the power off out front. Oh, please tell me you remember doing that. We did a whole bunch of those. Okay, and then we'll divide. So X will equal log 15 divided by the log of 6. Notice that's kind of the long way of getting exactly what we said it was going to be in the beginning. So if you can remember your shortcut, you go straight from here to here. That works every time, the log of this number over the log of this number. If you forget the shortcut, then you got to go through the long way but you will get exactly the same answer. Okay? Now, if you get your notes out, you will notice we're ready for part 3E on the back of page 28. And I want you to look at problems A, B, C, and D, because they are exactly the ones where we were taking the logarithm of both sides. I know it's really hard, guys, to pay attention even in person when I'm blabbing away at you, but man, you've got to pay attention, because we are not stopping or slowing down. We've got a ton of material to cover before we can put pre-calculus on your transcript. So we got to keep going. You got to stay on top of it. All right, I'm back in my notes, done lecturing you. I'm on the back of page 28. Put your little review problems away. I'm going to try to sneak a few of those in every day. Put those away on the back of page 28, section 3.5, part 3E, right where we left off yesterday. Shake the cobwebs out. Think about what we talked about yesterday. What's going to be step 1 solving this problem?
Do you put log in front of both of them?
Actually, I'm going to do that, but before I do that, there is something else that has to happen.
Divide.
Yep, I got to divide. You can't have this coefficient out here in front. So whatever kind of equation you have, even if this is a logarithm instead of an e or something, you need to get rid of this coefficient. So I'm going to divide by 81. Now, 81 does not go into 200 evenly. I mean, it doesn't give you an answer like 3 or something. So I'm going to leave it as 200 over 81. I know many of you are fraction phobic, but if you type that in and write down a rounded off decimal, it's going to impact your answer. Do not round off until the very end of the problem, okay? So you're just going to have a fraction for now. Now, we need this x out here in front. We need to be able to pull this x and put it in front. The only way you can do that, as Mary Kate said, is to put a log on both sides. Take the logarithm of both sides. But I want to remind you of something that I mentioned a long time ago. Since the problem has an e in it, instead of LOGing both sides, whoops, that's no good, I'm going to LN both sides. Now remember, ln is a logarithm, so it's perfectly okay to ln both sides. It is also perfectly okay to log both sides. But once again, since there's an e, using ln is a shortcut, because anytime you have an ln and an e touching each other, physically back to back, ln, e, like that, they're going to cancel. So what I'm going to type in on my calculator is simply this, ln 200 over 81. That's going to give me the answer to the question. If you used log, it's going to be a little bit bigger situation. Nothing will cancel, and you'll have more to type in, but you will get the same answer. Anytime I have an e in my problem, I like to use ln, because it always simplifies it. Okay, so ln 200 divided by 81, and 0.9039 is what I got. Does that look okay to everybody? Everybody find your ln button, ln 200 over 81. That was pretty easy. So you are allowed, when you have an x that's an exponent, and you know you need to get it down, you can log both sides, or you can ln both sides. I always use log unless there's an e in the problem. But I could always use ln, I could always use log regardless. That's just easier for me. All right, let's try the next one. Farrell, what do you think we might do to start? Divide, absolutely. This is exactly the same kind of problem. We're going to divide. And once again, I don't think 17 goes into 93. So I'm just going to leave it as a nice little fraction. And then Miriam, what will I do next?
Adding ln to both sides.
I'm going to take ln of both sides. That's a logarithm. It's the same as loging, but I'm using ln so that those will cancel. And all I have left over here is x equals ln of my fraction. So I will type in ln of my fraction. And that's a divided by, so it's ln 93 divided by 17. 1.6994. Okay, everybody ready? All right. G. Leo, what are you going to do first?
Do we divide first?
Absolutely. And this time, you can leave it as 200 over 50 if you want, but this time it actually does divide in evenly. So if you want to just say 4, you can. But you can also leave it as 200 over 50. I don't want you to get confused or worry about that. It doesn't matter. All right? Good. Zane, what happens now?
Do we put the ln in front of it?
Yep. We're going to ln both sides. We're going to take the natural logarithm of both sides. And of course, anytime that happens, it's gone. So negative 0.112x equals ln 4. And then this problem has one more step. Leo, what's going to be our last step if we're solving for x?
Our last step? Oh,
Leah. Yeah, that's okay. Okay, I didn't hear. What'd you say, Leah? Yeah.
X by itself, right?
Yeah, I have to get x by itself, so you're right. I'm going to divide. So this time, I'm going to take ln 4, whatever that is, and divide it by negative 0.112. Be really careful, as always, kids, you have to close that parentheses. So ln 4, close the parentheses, divided by negative 0.112, and I got negative 12.3776.
This for what page are we on?
We are now on page 29. We finished page 28, so we're now on page 29. And we're ready for letter H on page 29, section 3.5 number 3. I guess this is still part 3. Last one in this section. 3e to the 0.17x equals 19. Lainey, step 1.
Divide.
Yep, by 3. So e to the 0.17x equals 19/3. I can't simplify that, so this time I'm forced to leave it as 19/3. Okay, Jamel, what's next?
Don't you have to put in the ln?
We're going to ln both sides, yep. Because, first of all, I know I have to put a logarithm of some kind in because I got to pull that exponent off. If I use ln, that will just go away and all I have left is 0.17x. And then like the last one we did, this has a last step because if we're trying to get x by itself, we need to divide. So you just need to type that in carefully. It's easy, easy, easy. Make sure you close the parentheses. So ln 19 divided by 3, close parentheses, divided by 0.17. And I got 10.8578. Does that look all right to everybody? Okay, Farrell, you got this? I see you eyeballing it kind of strangely, or you're eyeballing something. You got it?
Yeah, it's cool.
Okay, it's cool. I wish it were cool in here. All right. Now we're going to do some of the same work, guys, except they're logarithmic equations. These equations we just finished, x was in the exponent. It's an exponential. Now we're doing them where x is part of the logarithm. All right, so let's look at this first problem, which looks very complicated. Very, very complicated. Does anyone have a thought? Look at it, it's an equation. Think about what you would do in a regular equation.
Would you subtract 3?
Exactly. Very good. We're going to subtract the 3. So we have -2 log 6. By the way, that is a negative. Don't lose it. -2 log 6, x plus 2, equals 2. I subtracted 3, so those are gone, and that makes 2. Very, very good. That's perfect. Now what?
Would you divide by -2?
Absolutely. This is a regular equation, guys. So we're dividing by -2. Just like you would in a regular equation. But this is where now things get different because it's a logarithm equation. You have done everything you can. You've gotten rid of every number you can. Now it's time to get rid of the logarithm. When all you have left is log something, then you got to get rid of the logarithm. We talked about this in our quick review we did a few minutes ago. How do I get rid of a logarithm? What process do I have to use?
The loop-de-loop.
The loop-de-loop, that's exactly right. So I start right here with the base number. So 6 to the -1st equals x plus 2. 6 to the -1st equals x plus 2. Listen to me. Every time you get your equation boiled down to where all you have left is the logarithm, then you got to get rid of the logarithm. And you get rid of the logarithm by loop-de-looing it. Okay? What's 6 to the negative first?
1/6.
Yep. Now I need to subtract 2, right? Now this is where all your powers of 4th grade math come into play, okay? We need a common denominator. So this is 1/6 minus 12/6. So the answer to my problem is negative 11/6. We will be taking a test over chapter 3 in person. Part of it will be no calculator, part of it will be with calculator. Obviously there are some problems we need a calculator. This is a no calculator problem. So you're going to have to remember how to subtract fractions if that happens. Common denominator. And there's your answer. Now that one's actually harder than the next one. Who has an idea about the next one? Brooke, have you said anything today? I don't think so. Tell me how I'm going to start this problem.
Would you add 2?
Absolutely, right on. You're going to treat it just like a regular equation. You're going to add 2, which is going to make that a 6. Clara, what's next?
Divide by 3.
Yep, perfect. ln x equals 2. I can go ahead and divide. Sometimes, you know, when we do that, we can't. But since 6 over 3 divides, I'll go ahead and do it. Take Sam's. Do you see that I have boiled my equation down? There really isn't anything else I can do. I need to get rid of the logarithm. This is a logarithm. I need to get rid of it. How do I do that?
Would you divide?
No.
That.
Yeah, we already did that, right.
Would you put the 2 up to the,
Yes, that's what I'm going to do. I need to remember that the base here is e. You're never going to see it written. You're going to have to just know that when it's an ln, the base is e. And then we're going to loop-de-loo, Tate. We're going to loop-de-loo. Okay, that's how we get rid of a logarithm. So I'm going to start with the e. It's going to be e to the 2nd. So you said put the 2 up. Yes, the 2 becomes the exponent equals x. And that's it. We can leave e squared as our answer. Very good. All right, let's look at the next one. It looks a little bit bigger. But again, please don't freak out. Big picture. Look at it as an equation. JP, what do you think? First step.
subtract the 2.
Absolutely. And the only thing that might trip you up here is that negative. That negative stays. So we subtracted the 2 from both sides. We're not quite ready to loop-de-loo. Kennedy, what do you think we might still need to do?
Do you divide the negative?
You do. That's like a -1 there, folks. So you're going to divide both sides by -1. So now we have our logarithm all by itself, which is exactly what we wanted. You must get that logarithm all by itself. Then you can loop-de-loo it. Now, when I loop-de-loo, I start with this number right here, right? But there isn't one there. Scruggs, what is the understood number that's on the bottom of this logarithm right here?
I don't know.
Oh my golly, gee whiz. We're going to write this down if we haven't already. If you have LOG, that means base 10.
Oh, I knew that.
If you have LN, that means base E. So when you have the symbol LOG, Jaden, and there is no number present, then you understand there's a 10 there. So when I loop-de-loo it now, I'm going to have 10 to the negative second equals x plus 1. 10 to the negative second equals x plus 1. What's 10 to the negative second? Lindsay? 10 to the negative second.
Is it negative 100?
No, it's got 100 in it, but it's not negative 100. Remember, negative exponents mean 1 over. Negative exponents mean 1 over. So it's actually 1 over 100. So 1 over 100 equals x plus 1. And you are solving for x, so you're going to have to subtract 1. So again, common denominator, that's going to be 1 100th minus 100 100ths. So negative 99 100ths is our answer. All right, anybody have a question about that one? All right, why don't you try the next one? See how far you can get with the next one. Let's see if you can come up with the answer or an answer to problem D. And then I'll have a volunteer walk us through it. If you get 50 as your answer, you did it right. So let me know if you get 50, and I'm going to have you walk us through the problem. All right, Clara, walk us through what you did.
So first I divided 5.
Okay,
over,
perfect.
and I got log 2x equals 2.
Beautiful.
And then I did my loop-de-loop and got 10
Okay,
to the second power equals 2x.
Exactly, because
And then
that's
I
a 10.
divided the 2x over, oh, well, then it was 100 equals 2x.
Yep, and then you divided by 2. Absolutely beautiful. So Clara had to remember a couple of things in that problem. She had to remember first she had to divide by 5. I hope everybody remembered to do that. You got to get rid of that coefficient. Then Clara had to remember that the base is 10 because all the problem has is an LOG. So then she loop-de-looed. 10 to the second is 2x. 10 to the second is 100. And then she just divided by 2. Very nicely done, Clara. Anybody else get 50 on that? Before, we went through it? Good job. Good job. Anybody not get 50 and have a question about it? Okay, let's try the next one. Now, the fact that this is a base 2 does not change anything about the way we do the problem. So you're going to do everything exactly the same. So go ahead, give that one a shot, see how far you can get with it. And then we'll have somebody help us again. Think about what you would do in a regular equation. That's how you start. And let me know if you got 4 as your answer. And if you did, I need you to walk me through it. So who wants to do it?
I got 4.
Okay, Kennedy, here we go.
Okay, so first I subtracted the 1 over 27.
Beautiful.
And then I divided the 3 on both sides.
Absolutely.
And then I got log 2x equals 2.
Yes.
And then I loop-de-loo and got 4.
2 to the second equals x. So x is 4. Very nicely done. Mary Kate, you got it too, right? Good job. Anybody have a question about that? Okay. Tell you what, let's have everybody try F. And then on the next page, 5A. Would you try F and 5A? Because they're exactly the same kind. We'll walk through those, and then we're going to do a different kind. I'm going to need some different volunteers, so I need everybody working on this. Make sure you're staying focused. For F, you're going to need a calculator. So for this one, you're going to need a calculator. For this one, you're not. This time, instead of me giving the answers, I want to hear some volunteer answers, and then someone who gets it right will share your steps. Gabe, Jamel, you're usually good for an answer too. Do you have an answer to either one of these?
Well, my calculator like died
Okay.
during yesterday's class, so I started at but didn't finish. And then number 5A, I was just looking at it, and I don't know, I think I know what to do, maybe.
All right, why don't you just tell me what you want to do with 5A?
Is 5A, is it like 5x plus 7, or wait. Oh, I don't know. Is it, yeah, I don't know. I don't know. I kind of spaced it, because the way I thought I could do it, I can't. So.
Well, I think you might be on the right track, but let's talk about 5A for a minute. I want you to notice that there's a difference between the way 5A looks and the way F looks over here. I hope in problem F you added 3 first, but in problem 5A, you're not going to subtract 7 because that's part of the logarithm equation. I mean, that's part of the logarithm part right there. That's all together. So for problem 5A, we're going to go straight to loop-de-loop. So 3 to the second equals 5x plus 7. Do you guys see what I'm talking about? This all belongs together. Over here, this belongs together, but you got to get rid of the 3 and rid of the 2. Here, you go straight to loop-de-loop. So the answer to this one, did anybody get 2/5?
I got that.
Good. So the logarithm is already by itself. There is nothing extra added onto it or multiplied by it or anything. It's already by itself. So when the logarithm is by itself, we go straight to the loop-de-loop step. For F, the logarithm is not by itself, so we got to get it by itself. Eventually, you're going to loop-de-loop, but not until you add the 3 and divide by the 2. Everybody okay to this step? Now, you have the logarithm by itself, so we're going to loop-de-loop it. So 3 to the 7/2 power, 3 to the 7/2 power equals x. Well, that's why I said you need a calculator. Nobody knows what 3 to the 7/2 is. So 3 raised, use your raised button, and then parentheses 7 divided by 2. Now some of your calculators, the new calculators, when you do this button, it automatically puts you up here. And you don't need to worry about the parentheses, but on my old calculator, I need parentheses. See if you can get 46.7654. If you got that, then you typed it in correctly. Raising 3 to the 7/2 power.
Hey, Miss Ford.
Yes.
So, where I got stopped though on the 5A one, I think, like, I just forgot, like I knew I had to do the, I don't know, like, you know, loop it around or whatever somewhere. I just couldn't, like, figure out why, but whenever the log is alone like that.
Yes. That's when you do it.
Yeah, that's when you can, like, do, like, and go around.
Yes.
Right?
Yes.
Okay.
All right. So that's why on this problem, for example, the very first things we do, move the 3, move the 2, so that the log is by itself. We can't get rid of the log until it's by itself.
All right, thank you.
All right. We're going to do one more problem, gang. And then I'll be done. This one looks a little bit different. It's problem B. Log x plus log x minus 3 equals 1. What's different about this one?
There's two logs.
Exactly. Now listen to me. Listen to me. I'm going to say something important. You can't ever have more than one logarithm on a side of an equation. You can't solve it. So what we're going to have to do is combine these into one logarithm. So instead of having a log plus a log, I'm going to combine that into one. You know how to do this. We did it before Christmas. If you have logarithms that are added together, you can make one logarithm by doing what with the x and the x minus 3? What do I need to do to them? Multiply them. Kids, you guys got to go back and look at those properties. You need to know them, and we don't have time to go back through that whole lesson again. Go back and look it over. When you add logarithms, the numbers are multiplied. So if I have a logarithm plus a logarithm, then the two things here are being multiplied when I put it together. You cannot have two logs. If they are added, you put them together as a multiplication. If that had been a minus, I would have put them together as a division. And I'm sure there'll be one of those in one of the coming examples. So this is the log of x squared minus 3x. I just distributed that, multiplied that. Now, I have one logarithm, that's good, and it's all by itself. So what do I do when I have one logarithm that is all by itself?
Loop it around.
I loop it around, that's exactly right. Since it's just an LOG, and there's no base on that, I'm going to go ahead and stick in the 10. I know there's a 10 there. And when I loop it around, as you say, it's going to be 10 to the first equals x squared minus 3x. Wait, what do I do with that? That's an x squared equation, a quadratic equation. What do I do with that?
Just subtract the 10 over and then factor?
Yep, that's exactly what I'm going to do. I'm going to subtract the 10 over. Remember, 10 to the first is just 10. And then, now, factoring is fine. This one factors. Of course, what other option do you have for a quadratic equation?
Quadratic.
Yes, ma'am. So you can use that if you don't want to factor it. This factors.
X minus 5.
Yep.
X plus 2.
That's exactly right. Very, very good. And then I can see I'm going to get two answers, right? And the answers are going to be 5 or negative 2, because I set those equal to 0. Most of you don't need to do that. You can do it in your head. But you set them equal to 0 and solve. Wow, that's a doozy. Luckily for us, we've got several more examples, and we'll work through them tomorrow, whenever I see you again, I guess Friday. But we're not quite done, because there's one more step in this problem. Negative 2 is extraneous, because if I go back to the original problem and put in negative 2, we talked about this before. Real quick, type it in on your calculator. What happens when you hit log -2? Does it work? No. So that's an extraneous answer. This cannot be negative. This cannot be negative. And if you put in -2, they're going to be negative. So we got to
Was
throw.
3.5 homework?
We got to throw out the -2, and the only answer is 5. Nope, we're not done with 3.5 yet. 3.5 is huge, so we're not ready for that homework yet. We will be after next time. If you want to try it, you probably can do most of the problems in it, but it isn't due yet. I'm not assigning it yet. Okay? All right, you guys have a great day. I will see you on Friday.
Thank you.
Bye.
Thank you. Thank you.
Bye-bye.
Bye, Ms. Ford.
Bye-bye. Have a good day.
You too.